Come on. All right, we're starting chapter 3. Chapter 3 is about systems of equations. So that means, lines and where they intersect. And we'll do things that aren't lines. We'll do things that aren't linear systems. Um, and you've done this before, the system where you have two lines. We'll do systems where you have not just x and y's, but x and y's and z's. And those get difficult to solve. If you make one mistake in your algebra at the beginning, you're lost for the rest of the problem. It is unfortunate. But anyway, we will learn how to solve a system with three variables. It'll have three equations to it usually. And we'll also do systems of inequalities. 22. So that question didn't make it onto the recording, just the answer. Okay, it's fine, no big deal. It's like, okay, so let's solve this system by graphing. Oops, I shouldn't have done that. There we go. I had to make the bracket by hand there. So two ways I could graph this system. One way would be to find x and y intercepts and graph. The other way would be to write in in slope-intercept form. It's already in standard form, and graph. How about with the top equation? I'll do that in intercepts, and the bottom equation I'll do that in slope. Slope-intercept form, and that way you'll see both ways. A little review on both ways. Yes, sir. Yes. So 2x plus 4y equals 12. First, I'll find the x-intercept by making y 0. So I get 2x plus 4 times 0 equals 12. Oh, 4 times 0 is 0. So 2x plus 0 is just 2x equals 12. Divide by 2. The x-intercept is 6. That is the point 6 comma 0. 1, 2, 3, 4, 5, 6. Okay. The y-intercept, I make the x 0. And I go 2 times 0 plus 4y equals 12. Well, that's 0 plus 4y equals 12, so that's just 4y equals 12. Divide by 4, and y equals 3, so that is the point 0 comma 3. 1, 2, 3. Boom. Make the line that connects those two. Let's see, use that one. Use your straight edge. You tend to get it a little better. Boom. Okay. The second equation, x plus y equals 2. Okay. No, you don't shade these. You only shade if you had inequalities. You may not shade. I will not pull up the smiley faces today, no matter what you want. I will not do smiley faces. All right, I'm going to turn this one into slope-intercept form by subtracting x from both sides, and I get y equals negative x plus 2, which means my slope is negative 1, and my y-intercept is 2. So let me graph that one. Y-intercept of 2, down 1, right 1, boom. Graph your line. Graph it this way too, just so I have a good graph here. Okay. Now, to solve this system by graphing, I need to figure out where those two lines are intersecting. Looks like from my graph, right about here, that looks like maybe 1, 2, negative 3, comma 1, 2, 3, 4, negative 3, 4. Now you may not get you may not get a very good answer by graphing unless you've graphed really carefully. So when you graph, you have to go back and check and see if that answer makes sense in the original equations. So I'll put that negative 3, 4 into the first equation, 2x plus 4y equals 12. Let me go to a red pen for my check. So 2 times negative 3 plus 4 times y, 4 times 4, is that equal to 12? So that's negative 6 plus 16. Oh, that ain't right. Equals 10. Okay, so I wasn't quite on it, was I? So I wonder where this intersection is going to be. Maybe it is at negative 2, 4? 16, yeah. So it must have been at negative 2, 4. Let's try that. That'll give us 12. And let's see if that works in the other equation. X plus y equals 2. Ah, yeah, that works in the other equation. Negative 2 plus 4, is that equal to 2? Yes. Now we've got a check mark for both. So my solution is at negative 2, 4. And that just goes to show you that when you go graphing, let's see. Let's see if I can erase that. Yes, I can. Looks like they actually hit 1, 2, 3, 4, right about here instead. So when you go to graph them, you don't always get an exact answer, and you don't always get the right answer when you graph if you don't graph very carefully. And I thought I graphed pretty darn carefully, but I guess I did not. Okay, so that's why you go back and check. Obviously, we have algebraic ways to get the exact answer, so we're not going to worry about this past today about getting a really good graph. Okay, now you need your graphing calculator. Got it out? So this is a problem where we're going to do a linear regression. Table shows the number of pair of shoes sold by 2 new employees at a shoe store. Woo. Find a linear model for each employee's sales. Use the graph of the models to predict the week in which they could sell the same number of pairs of shoes. Okay, week 1 Ed sold 50, week 2 55, week 3 63, blah blah blah. Joe, without an E. You think that's a girl named Joe? Yeah, since there's no E, maybe it's Josephine. Okay. Or Joelle. Um, so since we have this data rather than an equation, I'm going to use my calculator to make an equation for me. So in your calculator, you need to put the week data in list 1, Ed's data in list 2, and Joe's data in list 3. So do you remember how to do that? Stat, edit, clear your lists. Since these are very short lists, you will want to clear them rather than just trying to write over your lists. And there, you can see mine too. Okay. 1, 2, 3, 4 in list 1. 50, 55, 63, 67 in list 2. 40, 47, 56, 62 in list 3. Okay. First thing we're going to do